Welcome everyone. This video is continuation of the earlier video, that is location of roots of the quadratic equation. We have seen three cases for location of roots. Now case 4, we have already given the theory. So let us explain again. So case number 4, both the roots alpha and beta are greater than k, are greater than k. So look, we have already discussed in the previous class. So this is k and alpha and beta. So alpha and beta greater than k. So there are two cases for a greater than 0. For a greater than 0. So look, the parabola opens upward. So this one is k. So here this one is fk and a greater than 0. So a is positive, fk is positive. So first condition is a into fk greater than 0. Now a is vertex of the parabola. So what is the x coordinate? Minus b by a. So minus b by a, look, this one is greater than k. This lies right of this. So minus b by a greater than k. And it has two roots. First x-axis at 2 points. So obviously d greater than equals to 0. For case 2, look, you get same condition. So a less than 0, this is fk. So this is negative, a also negative. So a into fk greater than 0. This is minus b by twice a greater than k. So two roots d greater than 0. Now application. For what values of m belongs to R, both the roots of the equation x square minus 6mx plus 9m square minus 2m plus 2 equals to 0 exceeds 3. This means both the roots are greater than 3. So look, this one is 3. So both roots are greater than 3. So what is our condition? Conditions are these three. So a into fk greater than 0. So what is a? A is 1. A is 1. So 1 into fk. So this is fx, this one. So x is replaced by here 3, x is 3, k equals to 3. So a into f3 greater than 0. So here x is replaced by 3 and a is replaced by 1. So 3 square minus 6m into 3 plus 9m square minus 2m plus 2 greater than 0. So if you simplify 9m square minus 20m, so this is 9 and this is 2, so 11 greater than 0. Now factorize it. So 9m square minus 11m minus 9m plus 11 greater than 0. So 9m common, m minus 11, m common, 9m minus 11, minus 1 common, 9m minus 11 greater than 0. So what we are getting? 9m minus 11, m minus 1 greater than 0. So we have already discussed it is greater than in equation. So value lies outside the interval. So this is 1. 11 by 9 greater than 1. This is 1. So outside the interval. So m belongs to minus infinity comma 1 union 11 by 9 comma infinity. So from A into Fk we get this result. Now condition 2. So what is our condition 2? So minus b by twice a greater than k. What is k? K is 3. So b is 6m minus b. A is 1. So what we are getting? M greater than 1. So this is one condition. This is 1. And third one is, this is true for all cases. So d greater than equals to 0. Third case. So what is d? B square. So 36m square minus 4 into 1, 9m square minus 2m minus 2 greater than equals to 0. So 36m square cancel. So 8m plus 8 greater than equals to 0. So m greater than equals to 1. So we are getting 3 cases. Now you have to take the common region. So what will be the common region? So look from figure. So one value is 11 by 9. One value is 1. So look, m greater than 1. So this is m greater than 1. M greater than equals to 1. This is also one case. And third case is minus infinity to 1 and 1 by 9 to 11 by 9 to infinity. So this is third case. So which one is common? Look, this greater than 11 by 9. This is common part. So what is value of m? Answer will be 11 by 9 comma infinity. So m belongs to, this will be our answer, 11 by 9 comma infinity. So from case number 4, these type of problems are coming in different competitive examination. So if you see the graphical condition, so look, it will be very simple. Now case 5. So case 5. So case 5 is alpha and beta less than k. Both the roots are less than k. So figure will be like that. K, alpha, and this is beta. So if you consider a greater than 0, so look, so open upwards. So figure will be like that. This one. Like that. So this one is Fk. So A greater than 0. Number 2, A less than 0. So figure will be like that. Look, alpha, beta, this is K. So A less than 0, open downwards. So this type of figure you are getting. So this one is Fk, this is vertex A, this one is vertex A. So look, for figure 1, what is graphical condition? Condition that both the roots are less than K, So A greater than 0, this is Fk. Fk is positive, this ordinate. So A into Fk greater than 0. For the second one, A less than 0 and this is negative. So look, this one is minus d by twice A. This is vertex. This one is less than K. And obviously d greater than equals to 0. These are the 3 conditions you are getting. Now application. So both the roots are less than K. M square minus mx plus 1, x square minus mx plus 1 equals to 0. Find m belongs to R so that both roots are less than unity, that is 1. So K is replaced by 1. So look, so we try to solve this problem. So calculation is very simple here. So what is A? A is 1. So condition is A into Fk greater than 0. So 1 into F1 greater than 0. Unity. A is replaced by 1. Now what is F1? X is replaced by 1. So 1 minus m plus 1 greater than 0. So m minus m plus 2 greater than 0. So m lesser than 2. So 1 minus m plus 2. So A into Fk greater than 0. A into Fk greater than 0. So we are getting this one. Now second condition, minus b by twice A less than K. So minus a plus m by 2 less than 1. So here we are getting same condition, m less than 2. Now third condition, d greater than equals to 0. So what is d greater than equals to 0? So m square minus 4 into 1 greater than equals to 0. m minus 2, m plus 2 greater than equals to 0. So minus m belongs to greater than in equation minus infinity to minus 2 union 2 comma infinity. So this one. So now we find the common part. What is the common part? We draw the figure for this. This is 2, this is minus 2. So m less than minus 2. Figure will be like that. So not including. Second one also m less than minus 2. For third one, 2 to infinity. 2 to infinity. And this is minus infinity to 2. Minus infinity to 2. So this one. So which part is common? You look from this part. So minus 2 minus this one minus 2 to infinity. So what is our answer? So final answer is minus m belongs to minus infinity to 2. Minus infinity to 2. Now case 6, location of roots. 6. So both the roots are greater than k, both the roots are less than k. Then problem number 6. One is less than k, other is greater than k. So write alpha less than k less than beta. So roots lies between alpha and beta. Sorry, k lies between alpha and beta. K lies between alpha and beta. K lies between alpha and beta. So in each cases we are considering two cases. So this is k, this is alpha, this is beta. So a greater than 0, so this one is vertex. So figure will be like that. So this is vertex A. This is FK. FK. So what is our condition? A into FK. A into FK. A is positive, FK is negative. So A into FK less than 0. So for the second one, we get same condition. Look, this is alpha, this one is k, this one is beta. So A less than 0. So open. So this is downwards. This one. Look, this is FK. This is FK. FK is positive above x-axis. FK is positive and A less than 0. So you are getting same condition. A into FK less than 0. So this is our condition. Obviously, D greater than equals to 0. So greater than equals to 0. So look, the greater than 0 you may take because here roots are distinct. K lies between this. That is why we can take d greater than 0. So this is our conditions. So application. So from figure, so look, condition, you can write the condition very easily. So application, write a problem. Find for all p's. Find for all p so that 6 lies between the roots. So that 6 lies between the roots of, what is our equation? X square twice into p minus 3 into x plus 9 equals to 0. So x square plus 2 into p minus 3 into x plus 9 greater than equals to 0. So k is replaced by 6. K is replaced by 6. So what is our condition? A into fk less than 0. So what is k? A is 1. A is 1. This is 1. F6 less than 0. F6. X is replaced by 6. So 36. 2 into p minus 3 into 6 plus 9 less than 0. So 12p. So 18 into 2, 36 plus 9 less than 0. So p less than minus 3 by 4. We are getting one condition, p less than 9 by 4. From this you get the condition. Now look the second one. So write d greater than 0 implies, what is d? 4 into p minus 3 whole square minus 4 into 1 into 9 greater than 0. So for common, p minus 3 whole square minus 9 greater than 0. So simplify. P minus 3 plus 3. P minus 3 minus 3 greater than 0. So p into p minus 6 greater than 0. P into p minus 6 greater than 0. So what is p? P belongs to. So here we get p belongs to outside the interval minus infinity to 0 union 6 to infinity. Now we take common part. So common part, as you please, you can write directly or draw the figure. 6, this is 0, this is minus 3 by 4. So p less than minus 3 by 4, figure will be like that. This one is not included. And this is minus infinity to 0, this one, and 6 to infinity. So what is our common part? Minus 3 by 4, and this is minus infinity. So what is our final answer? P belongs to minus infinity minus 3 by 4. So very simple. So this is case 6. This is 6. Now case number 7. 7. So 4, 5, 6, 7. These are the most important cases. Exactly one road. Exactly one road lying between K1 and K2. One road lies between two numbers, K1 and K2. So what will be our figure? This is K1, this is K2. Suppose this is K2. One road lies between K1 and K2. So two cases, you know, A greater than 0. This is one case, A greater than 0. So this is alpha and this is beta. One root, that is alpha, lies between K1 and K2. So midpoint of alpha beta. So this one, A greater than 0. So figure will be like that. So this one. This is our figure. And for A less than 0, so same figure, x dash. This is K1, this is K2, this is beta, this is alpha. So this one. Alpha, beta. So write the conditions. So FK1. So this is FK1. Look, FK1. And this is FK2. So what is condition? FK1 into FK2. This is negative, this is positive. FK1, K2 less than 0. Less than 0. And look for this figure also. If we extend it, so FK1, this one is positive and FK2 is negative. So you are getting same condition. FK1 into FK2 less than 0. And number 2, D greater than 0. D greater than 0. So application. Find value of m for which exactly one root. So this is condition. We write this part. Find value of m for which exactly one root. Exactly one root of x square minus 2mx plus m square minus 1 equals to 0. lies in -2, 4. Exactly one root lies between this. So what is K1? K1 is 2, K2 is 4. So write FK1 into FK2 less than 0. This is our first condition. Now what is FK1? So K1 is 2. So F2, so K1 is -2. F of -2 into F of 4 less than 0. So F of -2, x is replaced by -2. So 4 plus 2m minus 2 whole square plus 2m plus m square minus 1 into x is replaced by 4, 16 minus 8m plus m square minus 1 less than 0. So we are getting m square plus 2m plus 3, and this one is m square minus 8m plus 15 equals to less than equals to 0. So if we simplify, this is m plus 1 into m plus 2. So m square, 3m, m square plus 2m plus 3. So no, 3m, 3 m into this m square. So m square minus 8m plus 15. So this one. So m is, look, what is f of -2? -2 whole square, this is 4. X is replaced by -2. So this will be 4m, I think, because factorization. So m plus 1. Now look, this is m plus 1, m plus 3. M square plus 4m is, and 15. So m minus 5m minus 3m. So m minus 3, m minus 5 less than 0. Less than 0. So from wavy curve method, look, this one is 5, this one is 3, this one -1, and this one is -3. So this one is less than 0. If we take m greater than 5, so this is positive, all are positive. So this part is positive. And in between 3 and 5, suppose 4. So this is positive, this is positive, this is positive. Only this one is negative. So this is negative. And if you take value between -1 and -3, -1 and -3, that is -2. So look, -2. So this is negative, this is positive. So total is, this is negative, this is positive. Total is negative, and this is negative, this is negative. So negative. So look, m -2. Suppose m equals to -2. In between -1 to 3, we take 0. So simplest value is 0. So this is 1, this is 3, and this is -3, this is -5. So it will be positive. And in between this -3 and -1, we can take m equals to -2. So m equals to -2, this one is negative, this one is negative. So this is positive. Now this one is negative, only this one is positive. Negative, 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 3 negative. So this is negative. So look, we get figure like that, this one, this type, then up to this, and less than 3 it is again positive, this type. So what is our solution? That is negative part. This is, so m belongs to, so look, m belongs to -3, -1 union 3, 5. So this is m. Now second condition, we get condition, using this condition we get result, but let us verify the second condition. What is our second condition? D greater than 0. D greater than 0. So 4m square minus 4 into 1 into m square minus 1 greater than 0. So 4 greater than 0, which is true, which is true for all m. So what is the common part? Common part is this one. So what is the final answer? So final answer is value of m. M belongs to -3 -1 union 3, 5. 3, 5. Now 8. This is case 8. Both the roots lying between K1 and K2. Both the roots lying between K1 and K2. K1 and K2. Both the roots lying between K1 and K2. So two cases exactly same. So look, K1 and K2. So both roots lying between K1 and K2. So open. So this one FK1, this is FK2, this is vertex. So for A less than 0, so from figure you can easily find the condition. So this is K2, this is beta, this is alpha. So open downwards. So figure will be like that. This is K1, this is K2. So what is our condition? A into, look, A into FK1, A into FK1. Here A into FK1. The condition A into FK1 greater than 0. So look, A into FK2, this is positive, A into FK2. So A into FK2 greater than 0. Now look, minus B by 2A, this is vertex, minus B by 2A less than K1. If we draw the figure, then condition is obvious and D greater than 0. So 1, 2, 3, 4. So application. So now application. Find values of a for which. Find values of a for which 4x square minus 2x plus a equals to 0 has two roots. Lie in minus 1 to plus 1. Minus 1 to plus 1. So look, so d greater than 0. What is d? 4 minus 4 into 4 into a greater than 0. So 1 minus 4a greater than 0. So 4a minus 1 less than. So a less than 1 by 4. We are getting one condition. A less than 1 by 4. Now a into a for minus 1 less than 0. So what is a? 1. A for minus 1. So 4 into minus 1 a whole square, this is 1, plus 2 plus a less than 0. That is a plus 6 less than 0. A less than minus 6. This is 2. Now a into f of 1 less than 0. So 1. What is f1? 4 minus 2 plus a less than 0. So a plus 2 less than 0. A less than minus 2. This is third case. And finally, minus 1 less than b by twice a. What is b? 2 by 2 into 4 less than what is k2? K2 is 1. So minus 1 less than 1 by 4 less than 1. So now we find the common conditions. Common conditions. So look, minus 6, then minus 2, and 1, 1 by 4. So a less than 1 by 4. So this one. A less than 1 by 4. A less than minus 6. A less than minus 2. And this is always true. So write the common condition. What is common condition? Common condition is a belongs to minus infinity, comma, minus infinity, comma, minus 6. Minus 6. So this is greater than 0, so a less than 1 by 4. So a into f1, a less than minus 6. This is a into f1. What is f1? f1 is 4 minus 2 plus a plus 2. So if we take the common value, we get this one. Now finally 9. So only one case is remaining. Condition for K1 and K2 lie between roots of the equation. K1 and K2 lie between roots of the equation. So K1 and K2, this is K2, this is K1, this is K1, and this is alpha, and this is beta. K1 and K2 lie between roots of the equation. So a greater than 0. So figure will be like that. So this one, this is fk1, this is fk2, and for a less than 0, so what we are getting, this is beta, this is k2, this is k1, and this is alpha. So figure will be like that, parabolic arch. So this is vertex, this one is vertex. So this is fk1, this is fk2. So what is the condition? Look, for the last case, condition for k1 and k2 lying between the roots. Look, for the first case, a, this is a into fk1, a into fk1 less than 0. This is a into fk2 less than 0 for first figure. For the second figure, look, this is positive, but a is less than 0. You are getting same in this case. So for all cases, in figure 1 and figure 2, you are getting same condition. So if you draw one figure, then you get the condition. No need of second one for solving problems. So application, and obviously d greater than equals to 0. So two roots. So this is d greater than. So write application. One application of it. For what value of what value of a, or what value of a, one root of a minus 5 into x square. X square minus 2x plus a minus 4 equals to 0 is smaller than 1, is smaller than 1 but greater than 2. Smaller than 1 but greater than 2. This is 2, this is 1, this is alpha, this is beta. For what value of a? So this is figure will be like that. A minus 5, a minus 5, this one. So a is replaced by a minus 5. So what is our condition? A minus 5, a is replaced by a minus 5 and f1 less than 0, a minus 5 into f2 less than 0. Obviously d greater than 0. Now we solve these equations. So what is f1? So a minus 5 for 1, a minus 5 unchanged. f1 is a minus 5 minus 2a plus a minus 4 less than 0. So a minus 5, 2a cancel. This is minus 9 less than 0. So a minus 5 greater than 0. A minus 5 greater than 0. Therefore, a greater than 5. Now from 2, a minus 5 into f2 less than 0. So a minus 5 unchanged. What is f2? X is replaced by 2. A minus 5 into 4 minus 4a plus a minus 4 less than 0. So a minus 5 unchanged. This is 4a, this one is 4a, 4a is cancelled. So a minus 20, a minus 24 less than 0. So this is less than equation, a belongs to 5 to 24. Now third condition. So what is the third condition? Third condition, d greater than 0, discriminant. So 4 square minus 4 into a minus 5, a minus 4 greater than 0. 4 square, a minus 5. So a square minus 9a plus 20 greater than 0. So a square is cancelled. 9a minus 20 greater than 0. So a greater than 20 by 9. So we are getting 3 cases. So finally we write the answer. So look, 24, this is 5 and a greater than 5 and this is approximately 20 by 9. So a greater than 20 by 9. This is 3. A greater than 20 by 9. A greater than 5. So this one. And finally 5 to 24. So what is the common region? I think common region is 5 to 24. So M belongs to 5 to 24. M belongs to 5 to 24. So location of roots. These are the 9 cases. From case 4 to 9, you get problem in each competitive examination. Now, few problems are given to this set in the description set. So, you please try to complete these problems. I think you can easily solve this problem if you know the conditions. So, thank you.